I'll do a completing the square additional example. You may have to go back to chapter 9.4 for Algebra 1 though to see where I'm getting some of these steps. All right, the first thing I want to do when I see this problem is get this negative 40 over to this other side and set it equal to 0. So I will add 40 to both sides and I'm lining it up with a constant. So I have negative 3x squared minus 24x plus 57 equals 0. Now I want to divide everything by a negative 3. It's going to be easier if I get rid of the negative. And 3 does go into each of these numbers. You see 5 plus 7 is 12 and 3 goes into 12. So that means 3 will go into 57. So I'm going to divide each term by negative 3. Even on the other side. So I'm left with x squared plus 8x, negative 24 divided by negative 3 is 8, minus 57 divided by 3 is 19, equals 0 divided by 3, which is 0. Okay, now I've got it set up and I'm ready to complete the square. I will now move 19 back to the other side of the equation so that I've got x squared plus 8x. Leave a spot for the c to complete the square with, and then 0 plus 19 is 19. All right, to complete the square, I take this b here, which is 8, and I half it, and I get 4. And then I take the 4 and I square it, and I get 16. So my C is 16. I can add 16 to this side as long as I add 16 to this other side. This is a perfect square trinomial, so I know I can factor it the shortcut method, which is to take the square root of x squared, which is x, the square root of 16, which is 4. And this always has to be a plus if it is a perfect square trinomial, but that means that both of these signs for both of them would be a positive, so that would be a plus here. Equals 19 plus 16, which is 35. Okay, to get the x alone, I need to get rid of the square, and the opposite of square is square root, so I'm going to take the square root of both sides. And keep in mind there will be a positive or negative answer there. The square cancels the square root out, so x plus 4 is now freed from the radical, and I have positive or negative root 35, which is not perfect, so I'm going to leave it like that. To get the x alone here, I will subtract 4 from both sides. And then I have a negative 4 plus root 35, but I also have a negative 4 minus root 35. Okay, let's put these into the calculator to see what they are. Negative 4 plus root 35 is 1.9160, so 1.916 approximately, rounded off to the nearest thousandths. And then negative 4 minus root, what did we say, 35, is negative 9.160, so negative 9.916 approximately. Whoops, and I wrote that symbol and I meant negative.